So let's take a look at creating a machine learning model for gait analysis. This doesn't have to be used for Parkinson's, but it can actually be used for any type of human movement analysis or machine learning classification. The first step is to take a video and to process it using media pipe pose landmarker. So let's go ahead and do that right now. As you can see in the directory here, we actually have a couple of videos, one for Parkinson's, which you can see here, and another one here for like a normal walking video, a normal walking pattern. And to start off the process to convert into CSV, you can just run the main.py, and it'll do the video conversion to CSV file, doing all of the feature engineering of all the things that we're interested in, specifically for Parkinson's disease here. So you can see here that the process has created two new folders. One is tabular and the other one's video. And if you look into the tabular folder, you can see that we have CSV files created for the normal walking pattern, and then also CSV files created for the Parkinson's walking pattern. And the second folder is a video folder. So if you look into the video folder, you can see that we have the stick figure video, and we've taken the stick figure video and overlaid it on top of the original video, which is that overlay.mp4. After you've created and extracted all of your CSV files from the original videos, you can place them into this data folder, and in the data folder, it's got a very specific configuration. So test, train, and validate, which each one of those folders is going to have a normal and a Parkinson's folder. And then to start the training process, you just go python train.py, and it'll start the training process based on the CSV files contained in those folders. Once your model is generated, you can go ahead into the demo predict folder. You can see a completed model that's for Apple Silicon. That's the Parkinson's classifier model complete. And then there's a test folder, which contains two files, one for normal gait and one for Parkinson's gait. They have the CSV files that you're going to pass through the model to give you a classification for each of those types of walking patterns. So if we go ahead and run the python predict.py, you can see that the normal CSV file is predicted as a normal gait with a confidence of 94.21%, and the Parkinson's.csv has been predicted to be Parkinson's gait pattern at a confidence of 99.99%. Finally, if you go ahead into the demo folder, you can see that we have the Parkinson's classifier model there along with our test folder. And this folder creates a voice assistant where you can actually query the model using speech to text and text to speech, where you can query the model about particular test results for patients. So let's go ahead and try to run this demo. This is going to go ahead and stand up a web page that you can navigate to. And if we click start, we can go ahead and talk into it, and we can get more information about Parkinson's disease. Let's go ahead and try it. Computer, tell me about Parkinson's disease.
Parkinson's disease is a progressive neurological disorder that primarily affects movement, causing symptoms like tremors, stiffness, and balance issues. It's caused by the degeneration of dopamine-producing neurons in the brain. And while there is no cure, various treatments can help manage symptoms.
Computer, get test results for patient number 1.
The analysis shows normal results, indicating that everything appears to be functioning as expected. This is a positive outcome, but if you have any concerns or questions, feel free to discuss them further.
Computer, get test results for patient number 2.
The analysis indicates a high likelihood of Parkinson's disease. It's important to discuss these results with your healthcare provider, who can guide you on the next steps and available options for management.
So there you have it. We basically take the speech to text so we can query our GenAI platform in DigitalOcean to get more information about Parkinson's. And we also use the text to speech in order to take the output from the GenAI platform to get a verbal result from our digital assistant. Hope you enjoyed the demo.